Good morning to everyone. My name is Wilmar Osorio. I came from the Research Center for Agri-Food and Biotech Development in the University of Lleida in Catalonia. And I'm here with Professor Gemma Villorbina, the head of our research center, and we are very pleased to be here with you this morning. And we want to share our experience in one of our projects in the center. What we want to share with you is our experience trying to go green in our territory. We describe some of aspects of a project in which we try to use forest local resources as an innovation push for our endeavors and progress in order to get a working biorefinery in our territory. And finally, we want to discuss with you some of the challenge and opportunities that we are seeing through this journal. Catalonia, it's in this corner of the continent, and we are very proud of our products. We have olives and olive oil, we have grapes and wine, and we have fruits. And these products are very important for our economy. In fact, the Catalonia society has been a farmers' society for centuries. And we have this beautiful monument in one of our squares in the city of Lleida that it's called the Farmers Monument. And you can see here a couple, a man and a woman with the products of the land, the fruits, the vegetables, and the tools that they use to harvest the land. And we still are a farmer society. And here we have two interesting examples of how we are going green and still being farmer society. In the first case, we have this new company that it's called Tal Cual Foods. You can go on internet. They start this company, this startup to recovery of discarded fruit to reduce food waste. There are a lot of fruit that can be sold in the big supermarkets because this fruit doesn't fit their quality standards to be sold there. So these guys get all this fruit, and you can purchase the fruit on internet, and they deliver you at your home. It's a very clever way to make new business with the products of the farm. And also we have also very interesting endeavors for the modernization of the pine resin extraction industry, a very old industry in Europe. So the question that we have is how to preserve our agricultural economy and at the same time evolve into a circular economy. So for this, and trying to answer this question, we think that the consolidation of an industry that will be able to produce high added value products, it's very important. And by high added value products, we mean high tech products, high quality products. And that these products must be fabricated or manufactured by raw materials from local, renewable, or waste biomass, and must be products that can reach strategic markets worldwide. Because all the products that I previously mentioned, the olive oil or the wine, are so important for our economy that we make a lot of exportation of this kind of products, and also the fruits, vegetables. But if we need a new products based on biomaterials, we need also very successful products in the market. So these products must be effective for replacing and surpassing current existing products in the local economies. And we think that platform chemicals and advanced materials, we do such a job. We want to share with you our experiences trying to do this kind of work. The question is that, as you can see in this graphic, if you take a look at the number of publications, this is a look at it in the scale through the years, you see that it's a very high interest in this question of biorefinery. Just get interesting products, like in the old case of oil refinery, but doing so using biomass. But the number of publications that go to pilot plant scale are very much lower. And the quantity of these studies that go directly to commercialization at industrial scale are even lower. So that's why we think that we must work in this research object, because, as you know, there are different types of maps you can see in the internet for biorefineries developed at the stage or at commercial stage in Europe. And we can see one of those maps in here. And in the region of Catalonia, there is a zoom over here, and we only have 3 or 4 initiatives for biorefineries. And no one of these is a bio-based biorefinery or biomaterial-driven biorefinery. So that's why we start to a series of projects which aim is to develop a biorefinery. So we are working in this project that it's titled, it's Boosting Circular Economy Through the Development of Biorefineries, Biorefinery Processes from Local Wood Biomass Wastes. It's a next generation project. The aim is the valorization of residual and low value wood in the region of Catalonia. We are trying to work with oak, pine, and chestnut sawdust from these 3 species, and applying a cascade biorefinery approach to get platform chemicals and advanced materials. We have 3 different sub-projects. Each one is developed by several institutions: the University of Lleida, the Universitat Rovira i Virgili in Tarragona, and the Center for Technological Forestry Center of Catalonia, the CTF. In these projects, we try to add in value to wood lignocellulose, preparing commercial compounds, trying catalytic valorization of this biomass waste, and also trying thermochemical processes. So we have these beautiful trees in the forest, and as there's a established industry of using of this wood, this material, we get these byproducts. We get these byproducts of wood, this sawdust, and pieces of wood that it doesn't fit the quality standards of the established industry for valorization of wood. So we try to figure out how to valorize this material. Here we see that, as all we know, this lignocellulosic material has 3 main components: lignin, in a percentage between 15 and 30%, hemicellulose between 18 and 10%, and cellulose between 30 and 50%. And you know that these polymers are the most abundant polymers on Earth, and we think that this material could be a great source of compounds that can be have an impact in our economies. But to do so, we need to design a biorefinery. And how we do that? Well, this is a very complex question, and there are a lot of people around the world working in this question, how to design biorefineries, because we have established a technology that it's oil refining, and oil refining takes more or less 100 years to be developed. And this technology, oil refinery, give us the way of life we have. So if we want, a new way of life, we need to spend a lot of time trying to develop the biorefinery concept and trying to make the same efforts as oil refinery industry do in order to produce the products that we have today and the products that give us the way of life we have. So we are trying to do this with a very simple approach. Let's try to get from this lignocellulosic biomass the three components by fractionation, and then starts to develop processes to get the valuable products. From cellulose, it is possible to get glucose by hydrolysis, and then get these two platform chemicals, hydroxymethylfurfural and chloromethylfurfural. And from these ones, we can synthesize biofuels. This is DMF, but it's not dimethylformamide, very dangerous solvent. It's called dimethylfuran, and this other one, dimethyl tetrahydrofuran, to kind of new biofuels based on biomass. From lignin, we think we can get modified lignins in order to get slow-release fertilizers for agriculture, and also get carbon quantum dots to fabricate or manufacture pressure sensors and pH sensors. And also for this solid fraction that you can get from this lignocellulosic biomass by different technologies like chemiocatalytic process, thermochemical process like pyrolysis. We think we can get also a solid fraction that can be used for agricultural applications, and the hemicellulose part can go through hydrolysis to important products like furfural and its derivatives like levulinic acid, that it's a bioplastic precursor, and using biotechnology, using microbes and bacteria, we are trying also to produce polyhydroxybutyrate as a bioplastic. So we have more or less 12 byproducts, 2 platform chemicals, 2 advanced materials, 2 biofuels, 2 products for agriculture, and 3 products for the wood industry that we get from this lignin in order to have bioadhesives for agricultural applications and for the wood industry. So let me show you some basic details about this topic. For fractionation of biomass, we use deep eutectic solvents or ionic liquids in order to go green. And after some procedures, we get the cellulose fraction and a lignin fraction. As you can see here, we have this aspect of the initial solvent, and after you treat the biomass, you get these 2 interesting solids. And what you can do is to get this lignin fraction and go through a bleaching or purification process of the material, and then try to functionalize this material in order to get adhesives. These some samples of our adhesives that we are testing for applications in the wood industry, using resistance tests that give us the information about the quality of this type of formaldehyde-free adhesives in order to be used in the wood industry. And also we are trying lignin upgrading by pyrolysis. For cellulose, we think that we can get this cellulose fraction from these raw materials, from this waste biomass, and after some purification unready solution in alternative cellulose solvents, we get this type of regenerated cellulose fibers that can be used for textiles and all the industry that is based on pulp in the current markets. Also, we get regenerated hydrocelluloses that can be used to advanced cellulosic materials with design properties. And for cellulose upgrading, we are trying an approach for hydrolysis in order to get these two platform chemicals and this precursor for biopolymers. Here I show you some of our results. We start from lab scale to bench scale and then to pilot plant scale. And as you can see here, we, using this process, get more or less this type of yield for this product, hydroxymethylfurfural. And we also have these technical and very complex problems related to the engineering of the process and the chemistry of the process. When you are trying to valorize this kind of materials, you get a lot of amines that are byproducts that are then reduce the yield to the desired products you want. But also we are trying to find applications for this type of materials that we are getting from this biomass. We have this project in which was the project for pilot plant scale processing of low-cost wood, and we started 2017 in order to get for our region a biorefinery. This was the design of the biorefinery, and now we have this beautiful building. When we have our equipments and we are installing and try to start to work with this pilot plant in order to get all these products, we are using these equipments and facilities in order to get the products I just described. And finally, we think that the challenge and opportunities are related to three main aspects. One, it's industrial ecology. It's very important for successful implementation of a circular-based economy. And by this, I mean local renewable resources must have a local impact. And that there is this trend of the waste to wealth. And also we think that there must be a trend of the wealth to waste. So we need to think positively about waste. So we need to give wealth to the issues related to waste. Chemical process scale-up is also a critical factor, and we think that chemistry plus engineering will overcome all this technical challenge. And also we have these tools like technology readiness level and other guides for process development that must be included in all these kind of projects. And we also think that product design is essential for innovative products that have enough added value, and more incorporated knowledge in these products means more added value, and that means finally big impact in the economy. So we are inviting you to go to Medwood Chem Lab. You can find our information in the web. This is a joint research and transfer unit aiming to promote the development of biorefineries and byproducts from Mediterranean agroforest ecosystems. And we have several research lines: development of biorefinery process, extraction and production of added value products, and development of bioadhesives for wood industry. Finally, again, we are a society of farmers, and we want to be in the future a society of farmers. We don't want to change that. We want to change our technology to survive using the resources of our land. So that's our final message for you. Thanks for your kind attention. And I will be pleased to answer all your questions or share with you some ideas about this topic.